Hello students, welcome to my channel Study Solution. Today in this video I am going to explain you how can you verify or prove whether a given number is irrational number or not using contradictory method. Okay, so let's start. First of all, you should know what is the term mean by contradictory. Contradictory means, suppose you have given a statement to prove. In this case, first of all, you need to think of that particular statement as a opposite or false statement. Then by the way, you have to prove in step by step way that no, that particular given condition that you have considered as false or wrong is finally correct. Okay, so according to our problem, we have to check whether this particular value root 2 is irrational number or not. Okay, so as the question is, we have to prove root 2 is irrational number. So using contradictory method, we have to first consider that it is a rational number. So let's start the answer, and you please watch the full video to understand the total process. Okay, so first of all, I have considered root 2 as a rational number, and meanwhile we will prove that no, it is not a rational number, it will be a irrational number. Okay, so let's start. Let root 2 be a rational number. Then root 2 can be represented in the form of p by q, because the definition of rational number was any number that can be represented in the form of p by q is a rational number, and we must have to consider it that p and q both should be integers, q not equal to 0, and p, q both the numbers shouldn't have any common factors except 1. Okay, so according to that definition, I have considered root 2 as a rational number, so root 2 can be represented in the form of p by q. So now we are squaring both sides. Okay, not in this line. Yes, it is. Squaring both sides. Okay, we get it. We get this line from this line by squaring both sides. Okay, so now we can cross multiply this particular equation, that will be converted to p square equal to 2q square. Okay, this 2 is multiplied with q square. Now here I have given this equation a equation number which is 1. Now you can see that this particular expression 2q square, okay, we can absolutely say that 2q square is divided by 2. Any number that is multiplied by 2 is divided by 2, isn't it? Suppose I have taken a number 10. So if I write 2 into 10, so 2 into 10, this total number can be divided by 2 and we will get the result 10. Okay, so according to that example, we can say that 2q square is divided by 2 because it is multiplied, q square is multiplied with 2. So 2q square can be divided by 2. So I have written here as 2 divides 2q square. Okay, That implies 2 divides p square. Look at this term, p square. Why? Because p square and 2q square are same. Both sides are same, na? So if 2 can divide 2q square, that means 2 can divide p square also. So I have written this line that as 2 divide 2q square, so 2 divides p square. And now you can see that this 2 is a prime number. Okay. So according to theorem 1 that we have discussed in our previous video, that any number square is divided by another number, then that particular number is divided by the same number. It was theorem 1. Okay. So according to this statement, if p square is divided by 2, that means p is also divided by 2. Okay, we got it from this line. So at this level we have got a point that p has a factor except 1, that is 2. As 2 divides p, that means p is 2 is a divisor of p. Okay. So come to the next point. Now I have considered p as 2m. Why? Because p is divided by 2, that means p is multiplication of 2. Let's consider an example. If we say that 8 is divided by 2, 8 is divided by 2, that means 8 is divided by 2. It's just an example I am giving here. Is divided Eight is divided by 2. That means 8 must be a form of 2 into 4, means you can see that 8 is multiplication of 2. That's why 8 is divided by 2. In this respect, we can see that we can say that 8 can be represented in form of 2 into something into 4. Here p in the same way, p can also be written in the form of 2 into m, where m is any integer. Okay, m can be 1, 2, 3, 4, whatever. As 2 divides p, that means p is multiplication of 2. Okay. Now substituting the value of p in equation 1. What was the equation 1? This one. Okay. As I am substituting the value of p, that is 2m, in the equation 1, that means in that particular position p will be replaced by 2m. So the equation will be 2m whole square equal to 2q square. So we will get particularly this line. Okay. That implies now we are squaring, we are evaluating the value, that is 4m square equal to 2q square. Now we divide both sides by 2, we will get 2m square equal to q square. Okay, now again that particular term has come, that 2m square. Okay, now here we have already discussed that 2q square is divided by 2. Similarly, in this point we can also say that 2m square is divided by 2. That means q square is also divided by 2, because these two things are same. 2m square equal to q square. So if 2m square is divided by 2, that means q square is also divided by 2. So here is the line. As 2 divides 2m square, that means 2 divides m square. Okay. But 2 is a prime number, which was again our theorem 1. So as 2 divides m square, that means from theorem 1 we can say that 2 divides q. Okay. Now here we again come to a point that 2 divides q, means q, which is the denominator, q has again a factor except 1. Okay, but according to the rational number theorem, rational number definition, we know that p and q, the numerator and the denominator of any rational number, must have only a common factor, which is 1. But in this particular example, we can see that p and q, both p and q, look at these particular points, p and q both have another factor except 1. Okay, thus p and q have a common factor 2. Both of them have a common factor 2 except 1. So this contradicts the definition of rational number. According to rational numbers definition, p and q cannot have more than one common difference, and common factor, and that particular common factor will be only 1. But in this example, we can see that p and q have a common factor 2 except 1. So our consideration that root 2 is a rational number is totally false, is not possible. That's why using contradictory method, we have proved that root 2 is not a rational number. Then a number which is not rational will definitely be irrational. So we conclude that root 2 is an irrational number. Hope you guys have already understand whatever I want to explain in this video. If you like the video, then please subscribe my channel so that I can give you all the required information about mathematics very easily. Thank you so much for watching the video till the end.